Okay, today we're going to be sketching. It's like our cross bounce, but the functions are going to be not in our factored form, and so we need to get it into factored form. So if we can factor, and we know how to sketch, which I think we do, cross bounce stuff, I think we're good. Okay, so the directions. Okay, you're going to factor, and then you're going to sketch it. Okay, and we'll ask a few questions about it as well, but pretty much we're just going to sketch. So number one. Okay, y is equal to negative x cubed plus 25x. Okay, y equals negative x cubed plus 25x. All right, well, first of all, we know a couple of things. Right now we don't really know how to sketch it, but we do know some things about the graph because we know what the degree is. What is the degree of this function? 3. 4 or 3? I heard a 4 out there. 4? Is it 3? Okay. It's 3 because why? It's the highest exponent. It's 3. When do we add the exponents to get? Okay, when they're in parentheses. Okay, good. So the degree is 3. We know it's odd, so they point in opposite directions. We have a leading coefficient of -1, so we know a lot about this graph, except where the x-intercepts are. Okay, so let's go and factor. So let's put it into the form where we like it to be in order to graph it. So how do we factor this? Take out a GCF. Good. So what can we take out? An x. In fact, a little bit better than the x. How about we take out a negative x? You'll see why in a second. So let's take out a negative x. Let's see, what do we have to put back in? So what do we have? So x squared, right, because that's negative x cubed, plus or minus? Minus 25. Right, so negative times a negative, positive 25. So we're good. There we go. Does this factor further? Yeah. It does. So y is equal to negative x times x, difference of two squares. X plus 5 times x minus 5. Okay, now does this look graphable? It does. So we're good. So let's go ahead and sketch it. All right, so the zeros, the x-intercepts, where are they at? Okay, -5 is one of them from that. 0 from this, right? Don't forget the x there. So 0. And also positive 5. There we go. And now we can sketch it. So we know it's odd. Degree is 3. It's odd. And so where do we start? Is it leading negative? Where do we start? Okay, up. There we go. Up on the left. Okay, normally an odd is low left, high right. But that flips it. Okay, so at -5, what are we supposed to do? Cross or bounce? Cross, because it's to the first. 0, we're supposed to cross because it's to the first power, and then cross, and it should point in opposite direction. There's our graph. There's our graph. Okay. Couple questions about this. How many relative minimums are there? 1. How many relative maxes are there? 1. Good. How many distinct x-intercepts are there? 3. How many roots are there? There's actually 3. What are roots? The degree. Whatever the degree is, that's the number of solutions. This degree is 3, you got 3 roots. Okay, good. Okay, number 2. Y is equal to -5 x to the 4th plus 125 x squared. Same thing, we'll factor and we'll sketch. Okay, so let's see. What can we factor out? Because we don't know how to graph it as is. Okay, we could pull out a -5 and an x squared. Okay, I agree. -5x squared. Okay, that leaves us with x squared minus 25. And that's it right there. You can always check by distributing. Make sure you Did it right. There you go. Perfect. That factors again. So y is equal to negative 5x squared. Difference of two squares. X plus 5. X minus 5. And that looks, again, very graphable, if that's a word. All right. It is now. We made it up. It's graphable. Okay, what's the x-intercepts? Where are they at? Negative 5. Is 0 an x-intercept? Yes, 0 is from that. And then also positive 5. There it is. All right, so the degree, what's the degree? Degree is 2? 4. There it is, 2, 3, 4. You can add it there. 2, 3, 4, or you can just look at the highest exponent there, but it's 4. Okay, which is even. Degree is even. Okay, where do we start the graph? Y down. There you go, leading negative, so down and down. Okay, if it was positive, be up and up. All right? Okay, so that's where we start. And we do the cross balancing. So at negative 5, we cross. At 0, we bounce because it's even. And then we cross, oops, sorry, and we cross, there we go. Okay, how many relative maxes do we have? 2 relative max. How many relative minimums? How many relative minimums? We have 1 right there. Right there. How many distinct x-intercepts? How many different x-axis intercepts do we have? 3. 1 there, 1 there, 1 there. There's 3 distinct x-intercepts. How many roots are there? 4. There's 4 solutions. 4 solutions. Here's one right there. There's actually 2 right there. 0 is a solution, and 0 is another solution. It's kind of a double root, they call it. And there's 1 right there. So there's 4. 1, 2, 3, 4. Okay? Okay, number 3. Short notes. We only have 4 problems. Okay, we have, let's see. Okay, let's say f of x equals x squared. So this is written a little differently. Same concept though. Let's say g of x equals 3x squared plus 15x minus 42. Okay, we want to graph y is equal to f times, it's a dot, times g of x. F times g of x. So this is not of, this is not a little o there, this is not f of g of x, this is not a composite, this is just literally f times. So it's f of x times g of x. So let's go ahead and write that, and then we'll graph it. So f of x is right there, times g of x. So we got x squared, that's f of x, times, so how do I write times? Just put in parentheses all that right there. Good. So times 3x squared plus 15x minus 42. There we go. There is f of x times g of x. Okay, a lot different from f of g of x. So we need to graph this. What do we need to do now? Factor, okay, factor. How do we, should we distribute the x squared in? Should we multiply it? No, because what are we going to have to do? We're going to have to factor it back out, right? Is there a GCF? There actually is. What can we take out of all 3 of those? A 3. Okay, so let's take a, so it's going to look like this. I want to take the 3 out, but I'm going to put it in front. But I'm still taking the 3 out. It's right there. There's a 3. There, it's all multiplication, so connected, yep. So what do we have left? So we take a 3 out, so we're left with 1x squared plus, so we're just taking it, right? So plus what? 5x. Right, we're taking the 3 out. Just happen to put it over there. A little bit because that x squared, well, do this, right? So we're taking out a 3, and there it is. So it leaves x squared plus 5x minus 14. Okay. Minus 14. There we go. Let's keep on factoring because it looks like this will factor. So y is equal to 3x squared times, let's see if this factors, 7 times 2, plus 7x minus 2x. There you go, plus 5. Perfect. Okay, now, good. Now we can graph it. Okay, so let's do that. Okay, let's get this. So these zeros are -7, 2, and also 0. Okay, also 0. Okay. So let's graph it. So where do we start? How do we know it starts up? It's positive, and it's even. Okay, because if it was positive and odd, we'd actually start down, right? So degree is 4, and so it's up and up, just like a parabola. And then positive, so that's correct. We start up, and let's do the cross bounce thing. So at -7, we cross or bounce? Cross, because it's to the first. At 0, we bounce, because it's squared exponent. And then I'm assuming we cross here, because it's odd, and there's our graph. Okay. How many distinct x-intercepts? How many distinct x-intercepts? 3. How many roots are there? 4. Degree is 4. How many relative maxes are there? 1 right there. Right there. How many relative mins? 2. There we go. Okay. Last one. Number 4. Okay, 4. F of x equals -x cubed. G of x equals -3x squared minus 10x. And I want you to sketch f minus g of x. So f minus g of x. Okay, so this is literally, if you want to write it, f of x minus g of x. That's just another way to write that. Okay, so let's go ahead and do that. Get caught up there. Okay, so f of x, so -x squared, and then minus g of x. So minus, so what do we have? So I just write g of x, parentheses. So minus this, because we're going to have to distribute the negative. So let's go ahead and write g of x. So -3x squared minus 10x. Absolutely correct. Cube. Sorry. Thank you. Yeah, so you're even correcting. Okay, so now what? We've got to graph it. Distribute. Okay, so y is equal to -x cubed plus, so we distribute a -1 to all three of those. So plus 3x squared plus 10x. Okay, good. So now we got to graph this. Well, is it ready to graph? Oh, GCF. Okay. So what is our GCF? Okay, x is common, but to make it a little easier, let's factor out a -x. Okay, -x. Okay, so we're left with what? X squared to get this. Keep going. Plus, well, we need a, right, minus 3x, because if I distribute negative times negative is a positive, right? So minus 3x minus 10. You can always distribute, make sure you get what you had to begin with. There we go. So far, so good. Perfect. What do we do now? Well, it's not quite ready to graph. We could factor this other trinomial here. Looks like 5 and 2, right? So x times x. You guys are getting good at factoring here. 5 times 2 is 10. We need a negative 3. Where is the negative 3 going to come from? Negative 5x, the inside, plus 2x, 5, negative 10. Perfect. And this is, as we say, graphable. Graphable, not laughable. Okay, 0 is one of them. 5 and negative 2. There we go. And now we graph it. So, Sydney, how do we start this graph? Up. Why is it up?
Because it's negative and odd.
There you go. It's odd. So normally it starts down, but the negative starts up. Perfect. Like this. Okay, and then Sam, who's not in her seat, but Sam, what do we do at each of these x-intercepts? We cross. Why do we cross? Okay, it's a degree of 3, true. They're to the first power. So they're all to an odd power. So at negative 2, this is to the first. We cross there. We cross there. And we cross there. So cross, and there we go. Okay, so it's as easy as our cross bounce as long as we can factor. Okay, any questions? Ready for the quiz?
No.
Sure. Okay, so is there homework on this? No, there's not. Yes, there is homework. Okay, it's the next section in the packet, 3.3. Okay, so 3.3 in the packet.
I thought we don't get it.
Okay. 2, 4.